FKuR Kunststoff adına global pazarlama ve satış yönetmeni Sayın Plastik Zimmermann şu an bir konuşma yapacak. Kendisini davet ediyoruz buraya ve kendisi de biyoplastikler çok katmanlı ekstrüzyonla değerin artırılması başlıklı konuşmasını yapacaklar. Sayın Zimmermann'ı davet ediyorum kürsüye.
My name is Patrick Zimmermann. I'm from the FKuR Plastik GmbH, or Kunststoff GmbH in Germany. And I would like to thank you for the invitation, being here in that beautiful city and that interesting country. And I would like to talk about the bioplastics and mainly about multi-layer extrusion. Okay. First of all, I would like to introduce, just a couple of minutes, our company. I would talk about plastics and sustainability, and I think I'm now the third or fourth one who's talking about sustainability. So just give me that minute. After that, I would like to talk about the multi-layer extrusion and some developments we made together with our customers. And finally, I would like to present you some successful market placements we already put into the market. All right. FKuR was founded in 1992, and we started as a research institute for plastic recycling, mainly. So at these days, we put a lot of effort into the post-consumer plastics. So let's say 98, plastic recycling was very well developed in Germany, and so we have to focus ourselves on very new business fields. And at these days, we cooperate with the Fraunhofer Institute Umsicht. Umsicht means environmental safety and energy technology. And all the resins we are developed, or we are presented to the market, are mutually developed with them. Between 1998 and 2003, we restructured our company into the company FKuR Kunststoff GmbH, which is a commercial compounding company and producing bioresins. We have a 100% commitment to do the most sustainable resins or renewable resins as possible. Actually, we're having 4 different materials available in the market. That's BioFlex. It is based on PLA, PHA, and different other biodegradable and compostable resins, except starch. So we do nothing in starch so far, for several reasons. BioGrade is based on a cellulose material. Fiberlone is a natural fiber reinforced material that can be polyprop, that can be PLA. And our newest development is Terraline. Terraline is based on the green PE produced by Braskem. That is the polyolefin which is produced by sugarcane. Well, plastics and sustainability. We hear a lot about plastics and we hear a lot about sustainability in the past. But I would like to start first with the nature and what, let's say, intelligent solutions nature offers us each day. And let's say, whenever we talk about natural packaging, we can start with some very nice solutions nature offers us, like the banana. First of all, the packaging of a banana is very interesting. It is an informative packaging which shows us clearly how ripe the product is. It turns from green to yellow, from yellow to black later on. And it says very clear how you can open it. I mean, probably you sometimes notice if when you try to open some small packages, you try the left edge, the right one, and you turn it around and you're not able to open the packages. A banana says very clearly, open me here. And most of the time it works, most of the time. And finally, after you consume the banana, you can throw the packaging away and it's a residue-free packaging. So that's nice. So that's a nice, let's say, solution nature offers us, and that is what we should keep in mind. I can continue that with, let's say, an apple. These small, very nice, this thin skin is nothing more than a very nice packaging, and it's eatable. Well, that's a brilliant solution. It's the same with an orange. It has a very nice gloss and a very nice shining, and it shows very clearly, here I am, buy me, I'm healthy, I'm nice. So it doesn't need any very, let's say, complex printing. And for those of you who are in the rigid packaging, nature offers a solution as well. And then we should compare the packaging nature is offering us today with our industrial packaging we have today. It's not in a way that I want to talk bad about packaging or plastic, for sure not. because packaging is our business, plastic is our business. And I would just want to keep in mind that nature offers some solution, and we should learn from that. The packaging we are using today is a result of our needs. We need the packaging for today that we have, because we have several needs. That product must be, let's say, transported or whatever. Make a simple example. Who of you would buy that product if it would be offered in a supermarket like that? Probably not so many, because we're expecting something. We're expecting packaging. We're expecting something that describe the product, that protect the product. It should extend the shelf life. It should be easy to transport. And of course, it should carry messages. We want to know what we buy. We want to know what's inside of the product. And that's the reason why packaging is so important for us. Well, coming to the sustainable issue. Sustainability was and is still a very nice, often used word in the past and today. But whenever I switched on the TV, most of the time I saw those words: sustainable economic growth, sustainable increase of profit. But the question is that really sustainable? What is sustainable? And there are a lot of definitions about sustainability, and we choose this one. This is the definition of the World Commission, and it says clearly that all the things we are producing or we need today should not have any negative influences in the future. I think that's a very good definition of sustainability. Finally, sustainability is even more than just economic growth. It is a global and overall concept. Probably it's a kind of philosophy. So the use of renewable resources is, from our point of view, a consequent out of that definition. And whenever we talk about bioplastics, they are part of that consequence. Bioplastics offering alternative waste routes and reduction of CO2. So we can categorize bioplastics in two different classes. First of all, biodegradable plastics. So they can be made from fossil resources, then can be made from renewable resources. And it says that those materials are, let's say, turning into CO2, biomass, and water. So biodegradation is measured by CO2 emission. Or in a bio-based content. So that means only renewable carbon resources. That means not that the biopolymer has to be compostable, like the green PE from Braskem. It's not compostable, but it's renewable. This slide shows where we are today with our plastics. We have here the non-degradable but petrochemical-based materials. We've got here the petrochemical-based materials but degradable plastics, like, for example, the PBAT from BASF. But even here, they are trying to increase the renewable content so that they will move here. We've got something like starch, PLA, PHA, and we've got the bio-PE, which is not degradable, but it's based on renewable resources. We've got the cellulose materials, which are more or less not degradable, but some of them are. And this is the area where FKuR is working in, so-called bio-blends of our resins. I talk about Terraline with our new product line, which we installed some weeks ago. And therefore, we've got now different options in different markets we can perform in. First of all, as I said, Terraline is not compostable, and therefore we have to go into different markets. Some markets we cannot, or because of the properties we can't achieve with the traditional biopolymers today. Barrier properties, for example. Biopolymers are breathable. Here we've got better barriers. Long-term applications is definitely something we see Terraline in, or green PE in general. But for short-term applications, waste bags, hygienic film, or something like that, compostability is an issue. Of course, in-house recycling is also, in the use of biopolymers, state-of-the-art. So again, That's the reason why people are choosing Terraline for some applications, or why they're using BioFlex. Compostable, non-compostable. Whenever we talk about bioplastic, it is important that the converter is able to produce the bioplastics on its common line. There should no need, let's say, for further investments or adjustments. That is the important thing, and that is the reason why we are modifying biopolymers like PLA or PHA. So the compounding of those polymers and turning them into ready-to-use resins is the key. So why I would like to talk about co-extrusion? Well, shopping bags and waste bags made out of biopolymers are common so far. That's probably the biggest application in the market, as well as mulch films. So we developed some new resins, clear resins, which can be used for the food packaging, for example. And we are using them, or our customers are using them mainly in the multi-layer extrusion to adjust the properties. So let's say, because our resins have similar viscosities, that makes it much easier in the extrusion. We have a very good interply strength, so we do not need any adhesive to combine each layer together. And of course, you are able to adjust the properties by a co-extrusion. That's a very important issue. And we increase the content of renewable resources. I will show you later. We've had a very high transparency and flexibility of the films. Good sealing strength, this is also important. We improved a bit the barrier properties. And as I said, the mechanical properties can be, let's say, combined or adjusted. Just an example, these are some BioFlex materials. And you see the modulus of elasticity in transverse and mesh in direction. And if we combine them into a multi-layer structure, you see that we, let's say, especially with this resin, we have a very stiff resin here, a more flexible here, and we combine it so that we make a much more flexible material. The property in general is a bit similar between, or let's say comparable with HDP to polyprop, if you like. Normally, I do not want to like to compare bioplastic with traditional ones because I think it's a class of its own. The same as elongation at break. You see that resin here, for example. It has nearly no elongation at break. It's a very stiff material. But in combination with that, we increase the elongation at break significantly. Same as in tear resistance. Well, that is a new combination I showed. It's processed on conventional LDPE 3-layer extrusion blown film lines. It has a very high transparency. The content of renewable resources depends on the film variation, on the layer variation, is between 60 to 80%. And of course, this film is compostable. What we now try to find out carefully is, because it seems that with that packaging, we are able to extend the shelf life in comparison to traditional plastics. Here we've got another formulation that looks quite the same, but as you see, the content of renewable resources is just 30 to 40%. That is a result because that material here is actually based on 100% on crude oil. But in the next 2 years, that should be increased also in its content. And so we will increase the content here up to 60 to 70%. Well, I will just show you some slides about some successful market placements as our customers realized so far with bioplastics. That is McCain. McCain is one of the biggest French fries producers in the world. He chose our material mainly in France and Belgium for his packaging of his biopotatoes. The target was to achieve a content of renewable resources of 70%. It is a multi-layer structure. Composting is possible, but not so needed, but it was an issue. It can be converted and filled on vertical form fill and seals equipment, on a standard material, standard equipment, sorry. We've got very good sealing strength, and the toughness at low temperature was important, as well as the printing. That was realized with our materials. That is a packaging which is done in Italy for soaps. Here also the content of renewable resources was very important. Compostability was and is a need still. It has a good resistance against the ingredients of the soap, and the barrier properties were also important. I mean, this is not a multi-layer structure, but it should show you where we are also and what kind of application. That is something we realized with Fujitsu, the back plate of that material, and as well the mouse. The mouse was launched January this year. Is made of biograde, so it's a cellulose-based material. And yeah, that is one of the largest market placements we made. So well, sustainability is still an issue. Compostability for short-term applications is, from our point of view, very important. For long-term applications, not that much. Biodegradation can be an issue. And finally, whenever we talk about multi-layer structure, we can achieve the properties by combining several biopolymers together. So, thank you very much for your attention.